Hello everyone, today we're going to see the campus bikes problem. Let's read the question. On a campus represented as a 2D grid there are n workers and m bikes with n less than or equal to m. Each worker and a bike is a 2D coordinate on this grid. Okay. Our goal is to assign a bike to each worker. Among the available bikes and workers, we choose the worker, bike pair with the shortest Manhattan distance between each other and assign the bike to that worker. If there are multiple worker, biker pairs with the same shortest Manhattan distance, we choose the pair with the shortest worker index. If there are multiple ways to do that, we choose the pair with the smallest bike index. We repeat this process until there are no available workers. The Manhattan distance between 2 points P1 and P2 is Manhattan of P1, P2 equal to the absolute distance difference between the x coordinate and the sum of the absolute difference between the y coordinates. So we're supposed to return a vector answer of length n, where answer of I is the index, 0 index of the bike, that the ith worker is assigned to. So let's look at an example. So if you see the first example, we have got a workers array and we've got a bikes array. They are two-dimensional arrays. And they're saying the worker 0 is at 0, 0. You see your worker 0 is at 0, 0. And the worker 1 is at 2, 1. There's a worker 1 at 2, 1. And bikes are at 1, 2 and 3, 3. So bike 0 is at 1, 2 and bike 1 is at 3, 3. Now they say the output is at 1, 0, which means the 0th worker is assigned to bike 1. The 0th worker is assigned to bike 1. And the second worker, the first worker, is assigned to bike 0. So the explanation given is worker 1 grabs bike 0 as their closest, right? There are no ties and they are very close. And worker 0 is assigned bike 1. So the output is 1, 0. If you take the Manhattan distance, between worker 1 and bike 0, worker 1 is 2, 1, right? And bike 0 is 1, 2. So 2 minus 1 is 1. 1 minus 2, the absolute value is anyhow 1. So 1 plus 1, which is 2. So the distance between them is 2. Whereas if you consider worker 0 and bike 0, right? So the distance is going to be 3. 0 minus 1, absolute value is 1. Plus 2 minus 0 is going to be 1 plus 2, which is 3. And if you see the third, this also, it is like 0, 0, right? And 3, 3. So for bike 1 also, he has a distance of 3 plus 3, which is 6. So anyhow he cannot take 0 because worker 1 is close to this person, and so worker 0 is forced to take the remaining bike 1. Okay, so let's take another example. And here you see the workers are at position 0, 0, 1, 1 and 2, 0, and bikes are at position 1, 0, 2, 2 and 2, 1. And if you see, worker 0 and worker 1 are close to bike 0. But then as per the problem, we should choose the worker that has the least index. So worker 0 is assigned to bike 0. And when you consider worker 1, again we've got a tie. Worker 1 is close to bike 2 and worker 2 is also close to bike 2. Again, by going with the least index, we should assign the bike 2 to worker 1. Okay. And the remaining bike is bike 1, which is assigned to bike worker 2. Okay. So that is the explanation, right? Now, if you see the notes section, these are important sections. So the coordinates, they're going to be less than 1000. So which means, let's say a worker is at index 0, 0, and let's say a bike is at index 999, 999. Then if you take the Manhattan distance, it is 999 plus 999, it is going to be 1998. So, and if you see the worker's length is going to be, the bike's length, it is going to be 10,000. Okay. So we're going to use a bucket sorting algorithm. So basically what we're going to do is we're going to group biker worker pairs based on the distance. So for example, let's say in this particular problem, see bike 0 is at 1 comma 0 and worker 0 is 0 comma 0 and the distance is 1. And if you take worker 1, this person is at 1 comma 1 and this is at 1 comma 0 and so the distance is 1. So at distance 1 we've got two possible assignments, 0 comma 0 and 1 comma 0. So basically we're going to bucket worker biker assignments based on distance. And then what we're going to do is once we've got the distance array in place, we're just going to see whether we can assign a worker and biker based on bike based on this distance, okay, based on the least assignment is for the index. And then we assign it, and once it is assigned and once we have the required number of bikes assigned to workers, then we can exit from the problem. So I'm going to have for a bucket sorting, we're going to have a distance array, and so going with this constraints, right, the coordinates can be at positions less than 1000. So less than 1000 is going to be equal to less than 999. So we'll take a worker at 0 comma 0 and a bike at 999,999. The total Manhattan distance is still going to be 1998, right? 1998. So the distance array list is going to be 1998. Okay. Um, so we will, since it starts from 0th index, so we'll have it at 1999. Okay. So let's start. So we'll iterate over the given arrays. Worker is less than number workers and worker plus plus. Okay. For next we'll take bike equal to 0 and bike is less than the number of bikes and bike plus plus. Let's say int distance is nothing but math dot abs plus math dot abs, the y coordinates, right? So the x coordinate we're iterating over workers. So workers of worker, the 0th is the x coordinate minus bikes of bike and the 0th coordinate. So I'm just going to copy and just change the index value for the second case. So the y coordinate will be the first index. So right, we've got the distance. Now if you see, then calculate the distance, and distance will be the index in this index array. And if you see, each index is going to have a list of integer arrays, right? So we have to check if this distance array has an entry for distance already. If not, then we have to initialize it. So if it is already there, then we have to just add this worker comma bike pair as an integer array. So we're going to say worker comma bike. Okay. So now we have calculated the distance array. Now let's have a counter which keeps track of the number of bikes assigned so far. Now we are going to iterate over this distance array. So distance equal to 0, and you can say the distance, maximum distance, it is less than or it's going to be 999, right? It's actually until 998, right? Distance is going to be until this, and distance plus plus. Now if we do not have any entry in distance array for this distance, then we can continue. We'll go ahead and explore the other possible pairs under other distance buckets. Okay. Now if this is not null, then we've got a list of integer arrays at this particular distance. So let's iterate over integer array and distance array of distance. Okay. So here an integer array, it is nothing but an array which holds only two values. One is a worker, right? So we'll say integer array of 0 is the worker. Worker is at index 1 because here we're putting a worker is index 1, and then we have bike and integer array of 1. Okay. Now what we're going to have is we're going to have two arrays. Okay, and let me have it here. We're going to say worker assignment equal to new end of number of workers. Okay, and we're going to have a bike assignment array which is going to have new end of the number of bikes. Okay, now we have, once an assignment happens, we should not disturb that assignment because we are already starting from distance equal to 0. So if an assignment has already happened, that means it is the optimal pair, right? So now if worker assignment of worker, so for for easier purposes, there may be situations where the distance between the bike and the worker is 0, right? Both are at 0 0, then it is going to be 0. So what we're going to do is we're just going to fill this arrays of worker assignment with -1 to know that it's not assigned yet, and we're going to do the same thing for bike assignment. Okay. Yeah. So once this worker assignment of worker, this is equal to -1, and the bike assignment of the bike, if this is equal to -1, and we have not reached the number of bikes that should be assigned, then we can go ahead and assign this bike to this particular worker, and then make sure that the bike assignment is also having the worker assigned, and then we will increment assigned bikes so that we are out of this loop. We're not processing when the number of assigned bikes are met, that threshold is met. So what we're going to do is, if assigned bikes, if this is equal to the number of bikes, right, we're going to break out of this loop so that we don't process unnecessarily. And this for ends here, we'll also break out of the outer loop, and basically we have to return the worker assignment because basically they are asking, like, the worker 0 is assigned to 0, and worker 1 is assigned to bike 2, and worker 3 is assigned to bike 1. So basically they're asking us to return the worker assignment. Okay, let's see whether we've got everything. So basically here we are using a bucket sort to basically bucketize, you know, worker and bike pairs as per the distance between them. And then here the worker assignment and the bike assignment. Once we do that, we have a worker assignment and bike assignment, and we process the distance arrays and process them based on the Manhattan distance and assign the bikes. Okay, looks good. Let's run this code. So it says it's a compile error, and that's because there's a spelling mistake here. And okay, so we have to add this. It's a list. We're adding this new array. Okay, sorry for that. Yeah, it's accepted. Let's submit it. You see, the runtime is 46 milliseconds. It is faster than 92.49% of the Java Online submissions, and memory usage is 85.5 MB. So memory usage is more. That's because we are using this distance array, right? And for bucketizing, and then we are also using the worker assignment array. And so if you consider the total complexity, it is going to be O of M end to N, because we are iterating over both the workers as well as the bikes. So, and the space is also going to be O of M end to N, because we're having all the arrays, where we're operating over M end to N. Okay, so that is how it is. So that is the campus bike problem. I hope you like it.